Okay, so if you're on a Mac, start up Xcode. If you're on Windows, start up Visual Studio, and then turn your computer around. I want to visually inspect to make sure that every person has done it. Okay, that's Visual Studio Code, not Visual Studio. Yeah, okay. That looks right. Okay, first row complete. There.
It's installing some components.
What?
It says installing components.
Okay, just turn it around. I want to see. That's Xcode?
Yeah.
Okay. And good.
Mine isn't launching anymore.
It's not launching anymore? Of course it did. Saw me. Please run the Visual Studio installer again. It's good. What do you know about a DaVinci Resolve?
Just a little bit.
Yeah. Okay, so I saw that yours was good. Can you turn yours? Good.
Like I was rewriting the super.
Visual Studio, Xcode, and you're going to pick a theme. So for the color theme, the cool kids always use dark, and then they try to work in dim light and discover they have to switch to light. Because it's, wait a minute, I got that backwards. Okay, so the cool kids choose dark, okay, well, enough said. All right. I can't use the dark because the dark theme really doesn't project well. And one thing that is true, the dark theme, if you're going to work in your dorm room at night, perhaps lying on your back in your spacious and deliciously comfortable king-size bed, which they have, I'm sure, is what they offer you in the dorms. And you don't want to disturb your roommate who is in the next king-size bed. The dark theme is wonderful because otherwise it would be just too bright. You'll disturb your roommate and your own eyes will get blown out. Okay, now let's take a look. There was no reading due today. There is reading due on Thursday. Are we all on top of that? Okay, so Thursday, chapters 1, 4, 6, and 7 are due not at 10:30, but at the 12:30. So let me correct that. Uh, 12:30 p.m. Okay. Very good. Now go to Windows users. Because we have shifted to Visual Studio, you no longer have access to wget, which you had under WSDL. Mac users, you still have wget. Please confirm by opening your terminal and typing wget. It should say that you didn't specify enough information rather than the command not found. Okay? Mac? Okay. So on Windows, please go to the class website. On Schoology, and I'm going to switch over to Windows so that I can do this along with you. Okay, so this wget.exe, so this is a Windows native version of wget. Click on it, and then click on it again. And what do you want to do with it? It's only 2 megabytes in size. Say open. Okay. So minimize, give yourself some room here. What I'd like you to do, let's just do it the easiest way that we can. Let's just drag that onto your desktop. Then click on your local disk C. Everybody with me? Double click on Windows. Scroll to the bottom, near the bottom, I should say. There's one that says System 32. System 32, everybody. So double click on that. Now make sure when you do this move that you are going to land in the System 32 directory, not in one of these subdirectories. Okay, so left click on wget and drag it way to the right until any blue line disappears. You see that blue line? You don't want that. You want to drag it to the right and let go. It's going to ask you for administrator because this is a secured directory, and go ahead and hit continue. Okay. So now wget is installed properly on your computer for Windows. All right. Let us begin, as we will always do, with review. Who's got questions about anything you've learned so far? Please.
So we talked about using the pound sign include IOStream.
Yes.
Do we always need to also use the include ctime?
No. Typically, for the benefit of the recording, the question is, we always use IOStream with an include. Will we also always use ctime? And the answer is not always. Ctime will be used whenever we want to use a random number generator, because you're using the time of day to initialize the random number sequence. So if we're going to use a random number in a project, we'll use ctime. Okay, other questions? All right, now barbecue this week is on Thursday. I hope to see more of you there. I'm very happy to see that everybody has the software installed. So thank you for that. Okay. Other questions for review? All right, you were responsible for 1.1, 1.2, 1.3. And as you can see on screen, there were very good completion rate. In 1.1, 97%, 1.2, 98%. 1.3 introduced the challenge activities, 90% of that, and 99% of participation. So good for you folks. Are there any problems in 1.1, 1.2, 1.3 that you'd like to go over in class? Everybody's good? So further relating to the reading, I'll finish the sentence and I'll come back to you. Also in relation to the reading, you might want to, after each reading, check your Schoology to see that an appropriate or a grade that sounds right has been entered for your reading. Okay. So, and if there's something there that really, really, really doesn't make sense, ask me about it. Okay, because I'm human, and even more so, I'm a scientist. I'm always looking for better data. I'm always ready to admit I'm wrong if I'm given a better argument or better data. Okay, therefore I cannot be a politician. Tara.
Can we challenge 1.3.4?
Okay, so that is 1.3. And we're looking for a challenge. All right, so I haven't found one yet. 1.3.1. I'm probably down at the bottom, isn't it? Okay. Is this the one?
Yeah.
Okay. So reading this, it says write two CIN statements to get input into the input values into birth month and birth year. Then write a statement to output the month, a dash, and the year, and end with a new line. The program will be tested with inputs 1, 2000, and then 5, 1950. For example, if the input was 1 and 2000, the output should look like 1-2000. Right? It says, note, the input values come from user inputs, so be sure to use CIN. Don't assign the values directly. So you'd place your cursor here and begin entering. Would someone like to guide me? Yes? Which directions do the arrows go? I guess now I'm totally confused, not only because we have two conflicting, but also because you're facing me. And I really don't know which way you mean. Should I do greater than, or less than, less than? Greater than, right.
Yeah.
Okay. And that'll go into birth, what did they say first? Month. And the other one is going to be similar. Okay. And now what do I need? See out, yes. And less than. You see how you're going to shove information onto the console. So it's the arrows are pointing towards the console. On line 8, you're getting information from the keyboard, and it's flowing into the variable. So that's why the arrows are pointing towards the variable. All right, so birth month. And then another set of less than, dash in double quotes, less than, birth year, and let's see, then write this, end with a new line. How do you do that? Okay, less than, and end L. Okay, now, let me scroll up. If you can't see it because of the scrolling and you're in the back of the room, just tell me. I can scroll up. So if this line were not here, so make believe this is not here, would any of these lines work? No. However, we could make them work either by adding that line or how? Right, so I'll just do that. We can mix. I'll just do that as an example here. STD : Now, if the using namespace is present, this is not going to hurt. Okay. Let's try run. And I'm happy as a clam. Okay. How about another one? Anybody? Okay. So let's go to the course page. 1810 lessons. Let's take a peek at lesson 1, and we've answered all of these. Do you have any questions about this code, which would be either review or a new question, whatever suits you? Perhaps a re-explanation of any of these questions? So there's some cool things that we saw in this. We saw a loop, which is a while some Boolean condition is true. Keep going. And we saw an if this, then that. Otherwise, if this, then that. Otherwise, do that stuff. We also learned that a break statement will seek out the closest and closing loop and stop the loop. Stopping the loop means that the execution will continue after the matching brace. So in this case, it'll continue where basically the mouse pointer is. Okay? All right. So let's move on to lesson 2. I'm not sure I'm going to have these prepared lessons for every lesson. This is a change for me. I'm not sure I'll continue doing it. Okay. Now, I thought that I had the wget. All right. So let me click here, and that looks good. Go to Schoology, send message. Okay. All right, so that is sent to you. So on Windows, let's see. There's my home directory. Yeah. Okay. So let's say CMD for the Windows command line. Very, very ugly, very primitive. Hasn't really changed since early 80s, late 70s, early 80s. Okay. Now, under Linux, we would say ls to see what's in a folder. Not true under the Windows command prompt. You say dir to show me what's in the directory. So you'll see something like this, certainly with differences. The Visual Studio is going to, well, for now, why don't we just do mkdir temp. Does anybody have a directory called temp already? Okay. And just like in Linux, that was the same as the Linux command, make a directory. This is the same as the Linux command, change directory to temp. And wget, and so copy and paste that command. So I sent you an email with this command in it. So copy that whole line and paste it into the command prompt in the temp directory. Yeah? The email hasn't come yet? Yeah. Okay. Try reloading your email.
Did you just send it?
I did send it. Of course, this won't. I sent it, didn't I? I'll do it again. Let me put wget in front of that. This is a space, correct? Yes. Okay. Hmm. Has anyone received the email? This is like not my semester.
It just started.
Hi.
Can we just type wget and then copy
Yeah, you can re-enter it, but I wanted to make it easier because it's pretty long.
or can we just copy that?
Copy that link. Oh yeah, duh. Yeah, so let's do it on Windows so that I'm doing the same thing as you. Okay, so why didn't I think of that? Let's go to GitHub, and I'm not signing in because it's public. And that's the one. Yeah, why didn't I think of that? Okay, lessons 2. Click on main CPP, but here's the important part. This is not the correct URL. You have to click on raw. Now you can copy that. Go to your command prompt, enter wget, and paste. And you should see something like that. Thank you so much for being smarter than me. Okay, how you doing? Okay. All right, so let's take a look at this program. Well, we could do it from here. Control plus. Okay. Talk to each other. What do you think this does? All right. First off, what do you think this is? I think you may have read about it or will read about it shortly. What is this right here, these lines? That's a multi-line comment. Multi-line comments are begun with /* and ended with //. Anything in between will be ignored by the compilers. All right. So I'm going to scroll up since that's just a comment. And that's as far as I can scroll. I'll use this screen. And I'll use this. Okay. What is the purpose of this line? The purpose of that line? Yep.
It calls, when you run it through the compiler, it will inject a bunch of things.
Yes, specifically the preprocessor part of the compilation process. Okay. And what does IOStream give us access to? Yep, see in and see out. Correct. And what is the purpose of using namespace std? To do less typing, exactly. So you notice that here it simply says C out, not STD : C out. All right. Age 1 and age 2 are examples of what? They're variables or integer variables if you look at the type. So variable declarations are always type, name, and then with an optional initializer. So variable declarations are always type, name, and then with that bracket there means optional, okay? It's not syntax. And then ends with a semicolon. So this is optional. So our example here is int age 1. And notice I could also have, if I'm declaring two variables of the same type, I can have a comma and then the second one. Okay, can you refresh my memory because I'm old and feeble? What are the rules for variable names? Can't start with a number. Good.
Can't be a keyword.
Can't be a keyword. Good.
No special symbols.
No special symbols. What symbols can you use? Letters and numbers, upper and lower case. Is this the same as this? Are these equivalent? No, case is counted, right? So the capital G makes this an entirely different variable than the one that came before. Okay, so case matters. All right, talk about it. Take a few minutes. What does this program do? You can go ahead and talk out loud. Okay.
Yeah.
So encoded in this program are various facts about ages. So, for instance, what is the minimum driving age in Wisconsin at least? 16 and a half? Really?
Solo driving is 16 permanently.
Okay, solo driving, 16. Right. So the first thing to notice is that the syntax is saying if, and there's a parenthesis. So in this language, the parentheses always surround the Boolean condition that we're going to test, the Boolean expression. What does Boolean mean? True, false. Yes, no. Okay. All right. So if age 1 is greater than or equal to 16, and this is the ampersand is the logical and. So let me write that down. Logical and is ampersand. Now, I did use the word logical on purpose because there is another kind of and in the language that works on bits, and we're not using that right now. So if you see 2 ampersands in a row, that's a logical and. It's working with true, false. So how does and work? So input 1, and here's input 2. True, false, false. So here's a table. Is my laptop screen in the way? Quiet, you could admit it. We're friends here. Okay. All right. So this table is called a truth table. Okay. If input 1 is true and input 2 is true, what is the result? True. Right. If input 1 is false and input 2 is true, what is the result of the and? False, correct. And in fact, you'll see that with logical and, if either of the inputs is a false, the output is false. Okay? So in this code, both can drive will only be printed if age 1 and age 2 are both greater than or equal to 16. Okay? So here's a little gotcha. What if this equal sign weren't there? If age 1 is greater than 16, not greater than or equal to? Because you say, well, I turned 16 yesterday, right? So I'm greater than 16. Would that work for the computer using integers? No, it wouldn't. Because my 16 and 1/365th is a fraction. Integers don't know about fractions. So according to the computer language, I would have to be 17 or more in order for this to be true. So that's why it's greater than or equal to. Right? Any questions about the logical and? Let's turn to the board here, make another important point. In English, we often use a conjunction with an implied subject. So if Mary is older than 21 and less than 99, who's less than 99? Mary, right? But Mary isn't mentioned here. So in English, this is normal. But you can't do that in our programming language. So you can't say and less than 99. So this is a kind of a translation of the English. This is not allowed. You would have to spell out the variable name a second time. Okay, so go ahead.
Couldn't you do if 21 less than age Mary, greater than 99? Or less than 99?
Okay.
Age Mary in the middle.
In math you could, but not in this language. So let me write down what I think you said. So you were hoping that the syntax would allow you to do this. Actually, that would be less. So you were hoping I could do that.
Yeah.
So in math, that would be valid, but our programming language doesn't allow that. Great question. Okay? All right, any questions about that? Because the eraser is in my hand. Yeah? All right. I kind of miss the days of chalk because after every class, I would exit the classroom covered in chalk, and I felt like a real professor. So this produces much less residue. So, okay. Now, how about that next line here? If age 1 is greater than or equal to 21, or age 2 is greater than or equal to 21. So the two, I gave away part of it. Logical or is expressed as two, CS people call those pipes, pipe symbols. It's the character that is above the bash, the backslash, on your typical QWERTY keyboard. Everybody knows why the typical keyboard is called a QWERTY keyboard? Look at the top line, QWERTY, QWERTY. Mm-hmm. All right, so pipe is logical or. Let's do a truth table for that. Input 1, true, false. Input 2, true, false. If input 1 is true and input 2 is true, what do you think the result is?
True.
True. If input 1 is false and input 2 is true, what do you think the result is?
True.
True, that's right. And in fact, the flip of the logical AND is going on here. If any of the inputs are true, the output is true. The output is false only if both inputs are false. So it's very nicely the mirror, it's the flip of AND. So if age 1 is greater than or equal to 21, or age 2 is greater than or equal to 21, notice it says at least 1, because it didn't count how many are able to drive. It just is saying that at least one of them are able to drive. Any questions about that? Okay, now this next one's a little harder. Silly Windows. All right. Let me make sure that's up higher. Now, why is this one more complex? How do we parse this? If age 1 is greater than or equal to 25 and age 2 is less than, not less than or equal, but less than 25, or age 1 less than 25 and age 2 greater than or equal to 25, then one can be a senator. Okay? Let's break this down a little bit. So let's say this is the whole expression. Okay, let's say that's the whole expression. So there's an or here, not 11, that's an or. And then there's a left-hand side and a right-hand side. And then there's an and an and over here. Now, how do I know that the precedence is like this? Because of the parentheses. Okay. One of the first things to note is that the parentheses all balance out. So over here I have 0 parentheses. 1, 2, 1, 2, 1, 0. You see how I got back to 0? That shows that they are balanced. Okay? Should I do that again? So if I add for every left and I subtract for every right, I start out at 0, 1, 2, 1, 2, 1, 0. And it's balanced if you get back to 0. Kind of cool way of looking at it. All right. So like precedence, the use of parentheses for precedence in math, those rules are the same in our language. So you would do what's inside the parentheses first. So the compiler will perform this calculation first, and this calculation second, and then, so this calculation first, this calculation second, and then this calculation third. Okay. So what else? Why do we have this kind of construction? What are we looking at there? We're trying to identify exactly one can be a senator. Notice before it was at least one, and that was just a simple or. So why is this put together the way it is? You're looking at 2 cases. If age 1 is good, age 2 better be bad. Or age 1 better be bad and age 2 better be good. So either we're looking for just one. So either it's age 1 is good and age 2 is bad, or age 1 is bad and age 2 is good. Okay? So you can build up really sophisticated Boolean expressions using parentheses. Okay? Anybody have any questions about this code? All right, at this point, is your Visual Studio open? And is your Xcode open? Okay, so I'm starting up Visual Studio, and it might look like this. So what we're going to do, I'm going to open up Visual Studio, and it might look something like this. We're going to create a new project when, of course, we want to create a new project. Go to Console App. Console App. Hit Next. And I'm going to give it a name. Let's say Ages. The project name will also become the solution name. It turns out you can put more than one project under a solution. So a solution is kind of an umbrella for one or more projects in Windows. Also take note of where it's going. So for you, it's going to be see users, your username, source, and repos. Okay, hit Next. It will chug for a bit. And then open up. So you should see something like this. Okay. The left-hand side says Solution Explorer. You'll notice that the project is in bold, and under the project, there are several potential folder-like objects, including source files. If I dial that down, I have ages.cpp. If I double-click that, if this were closed, and I double-click that, it would open up. Okay. Now let's go to Xcode. Welcome to Xcode. See, Mac is friendly. It says welcome. Okay, so let's create a new Xcode project. So that was the choice in the middle. You'll want to select Mac OS because we're working on your Mac. Then Command Line Tool. Then Next. Now we have a lot of stuff to fill in here. I'm going to call it again, Ages. My organization name probably is filled out for you. Maybe it's your name. Is it your name? Or you got to fill in something. And my organization identifier is totally lack of organization. Okay. Now, your language probably comes up as Swift. Don't do that. Don't do Swift. Instead, click on the word Swift and select C++. And hit Next. Now, select a place to put the project. I'll put it here. Let's see. Yeah, good. I don't have one. So put that wherever you want using the magical Macintosh directory selector. Okay? But make sure you remember where you put it, because we need to drop something in there. Hit Create. And now the Mac's not quite so friendly anymore, is it? Blah! All right, let's not get carried away with this screen. Instead, this is kind of like the Solution Explorer on Windows, this left-hand side. You'll notice that you can dial down ages and then dial down ages again. And there's main.cpp. Double-clicking on that opens up this. So both of these programs are functionally the same. They do look a little different. The one on the Mac is more correct. Okay. Now, I'm going to point out some of the differences, the first one of which is this scary looking thing on the Mac. That's pretty scary looking. We're not going to find out what that is yet. But you'll notice on the Windows template, it isn't there. And that's okay. Very good? All right. The other thing is the Mac, line 14, has return 0. And the Windows version does not. The Windows version is wrong. The Mac version is correct. There should be a return 0 there. Now, the fact that it's returning something, what do you think that is? Returning. Main is an example of a what? Starts with an F. And then a U. But don't get carried away. FU, right? And then rest? Function. Right. Good. Okay? So main is an example of a function. Functions all, do you remember, I think I erased it. No, I didn't. So do you remember all variable names declarations look like this? Type name with an optional value. Well, all functions are declared with type, name, parenthesis, left parenthesis. This part is optional. Close parenthesis, and then a starting brace. And the starting brace must, of course, be balanced with an ending brace. So let's see if some of those elements are common to both programs, Mac and Windows. There's type, name, left parenthesis, right parenthesis, open brace, close brace. Good for Windows. Let's go to the Mac. Int, main. So the type is int, the name is main, open parenthesis, then some arguments, which, as I mentioned, we're going to ignore. Close parenthesis, a brace, and a matching brace. Notice another couple of differences. The style of the braces. What's different about the Windows version and the Mac version? Windows, Mac. You're getting sleepy. Okay? So what about the braces? What's different? Yeah. They seem to be aligned differently, right? Okay. So this default style, this is a matter of style. The default style on Visual Studio is to place braces in this way. And everything that's inside this function is going to be indented by one tab stop at least. Okay? Now on the Macintosh, the default style, I'm going to erase this now. Everybody cool with that? Okay. All right. Now on the Mac Xcode, the default style goes this way. Where the beginning brace is on the same line as the function declaration. And then everything that's part of this function is, again, indented by at least one tab stop. Same here. So which one is better? First of all, first question, does it matter? Okay, does not matter. Because whether or not you have a space brace or a new line brace, that's all examples of white space, and white space doesn't matter. So these are examples of styles. And some people think one is more clear. Other people think another is more clear. But it's a matter of personal preference. Okay. Now, the important thing about style is pick a style and stick with it. Don't mix styles in the same program. When you go out into the field, you'll join a team, almost certainly, because computer science and programming is a collaborative effort. Gone are the days that the world is changed by one coder in a dark basement. Okay, all or nearly all programs of any consequence are built by teams. So you go out there and you join a team. The first thing that you'll want to know is what is the team's style. And even if it's not your style, you got to stick with the team's style. Because everybody on the team needs to be able to read the code and feel comfortable with the code. That's why they'll standardize on a style. Okay, good? Good. Now, getting back to this return, what is 0 that you see here? What's its type? Its type is, well, it's the number 0, right? The value 0. It's not the letter 0 or a string 0. It's the number 0. But what's its type? Louder, please. Louder? Anybody? It's a line number? Oh, I'm referring to this 0 on line 9. Yeah, anybody?
It sends back to the program that ran
That's a more correct answer than I wanted. I wanted a less correct answer.
It does the thing that one
Okay, so anyway, notice that 0 is an integer. And what is the type of this function? Integer. Right. So whatever type the function is, there has to be, with one exception, that I'll explain in a minute, there has to be a return of something of the same type. Okay? So this is int main, it's got to return a 0. So it would be incorrect not to include that return of 0. Yes?
Can't you return like 1?
That goes to the answer that Jordan gave. What Jordan said was this number is whatever's returned from main is returned to the program that called your program. And that's detail that we don't need to know right now. But to answer your question a little bit better, 0 means no error by convention. So if main returns 0, all is well. Okay? Any other questions? Tarek?
So do we usually put like return 0?
Hmm?
Do we usually put return 0?
Yes, we usually do. Unless we want to report that an error occurred. And I'll be happy in a later class to show an example of that. Bart?
Does us making mistakes in our code make the response a different number?
I'm pretty sure I get your question. And recall there are different types of errors. Among them, logical errors, which means that you've gotten into a situation which is functionally incorrect. There are syntax errors, which means the program won't compile. There's also linker errors, which we haven't gotten to yet. But there's also runtime errors. So let's say the program was supposed to read from a file. And if the file was read and all it went well, we'd return 0. But suppose we couldn't find the file. It would be appropriate to return a number other than 0. So, in answer to your question is, returning other than 0 is probably a sign you wrote a good program, because you were checking for runtime errors. Like, I couldn't open the file I was supposed to. Okay, so good observation. All right? Okay, now, on Windows, you can hit Control S. Let's see an example of running the program. You can hit the green the play button. It's compiling. And it ran in its own window. Very nice. It did the program, and it's waiting for you to hit any key to close the window. It has been the case where folks have looked at this and not known what to do, because they look at their keyboard and they can't find the any key. Not kidding. So any key means it's any of the keys that you see on your keyboard. Okay? No, because you have to hit enter. Well, I look down, there's an enter key. You have to hit shift. Well, it says shift. Which one is the any key? Don't know. On the Mac, it's going to behave a little bit differently. After all, Apple, think different. The same thing here is I have a play button, and I'll just click it. The build succeeded, and it's running. And it's running. Ah, there it is. The window holding the results is being shown inside of Xcode, which can be a real pain. And we may have to disable that in the future, but for now, it's all good. Okay? Has everyone been able to duplicate what I've done? Great. Okay, so on Windows, now let's overwrite this template with our real code. Do you remember that you put in the command prompt, you put main.cpp somewhere? I put it in a temp directory. So I can go into Explorer, and I should be able to find temp. I can double click on it, and main CPP should be there. Yes? Okay, let's put that window aside. In Visual Studio, see the tab that says ages.cpp, the tab up here? You can right click on that and choose Open Containing Folder. And ta-da, we have an Explorer window that has ages.cpp in it. So I'm going to drag main CPP over to the other window. And select ages.cpp and delete it. That's not what I did. That's okay, so I'll have to right click and delete. Then rename main CPP to ages. Is everybody with me on Windows? Okay. Let me reconstruct what I started with. That'll take just a moment. This. Okay, so starting from here, you're wondering how to open this window?
Yeah.
Okay. So go to Visual Studio. There is Ages CPP is showing up in its own tab. So at the top, click on the tab name and right-click, Open Containing Folder. And this window should show up. Are we good now? Okay, now let's complete the process. So drag main over to drag main. Please stop. Drag main over to ages. And then select ages and delete it. And then select main. And you can just singly click on the name main and type in ages. Yes? The temp folder. All right. What I did is, so starting from no window open, are you able to help?
Yeah.
Okay, goody. It's easy? The temp folder. Okay, so what I'm going to do is go to the Explorer and click on File Explorer because I already had one window up. And it showed up for me as a frequent frequent folder. Now maybe it doesn't for you, so let's do that. Okay. All right, so let's make a shortcut. Interestingly, you notice that none of these are your home directory. Desktop, yeah, that's in my home directory, but it's not my actual home directory. And it just says quick access. Downloads, that's in my home directory, but it doesn't help me get to my home directory. Documents. Okay, so let's make a shortcut to your home directory. So follow me, click on this PC, then double click on local disk C:, double click on users, and single click on your username. Just a single left click. Then do a right click and pin to quick access. On mine, it's the third one down. Is that good for you? All right. So now on your quick access, you should have your username. And if you click once on that, temp will be visible, one of the folders visible. Good. I love it when it works. Okay. Now on the Macintosh, do you remember where you downloaded, did the wget? Do you remember where the main.cpp is? Okay. Now, if you get lost and you don't know where your source code is, here, watch what I'm going to do. Go away. Now, all these fading in and fading out. After a while, you know, at first it's kind of cool. Oh, look, it faded in, it faded out. Just think about that. While you're waiting for this stupid effect to go, your life is ticking away. It's just frittering away. You're that many seconds closer to death. Isn't it nice? Wasn't that a real upper? Okay. So in this Xcode, looking at the code, I'm going to hover over main.cpp, and the pop-up is reminding me where that file is located. The other thing you could do is a little less helpful in this case, but on the left-hand side, in what in Windows would be the Solution Explorer, you can click on the file name, right-click, and say, Show in Finder. And that will bring up the Finder. This is a little less useful for now. This would be really useful for handing in your work in Schoology, because you could just upload it right from there. Okay. So my source code is located in, wow, that's a long one. All right. What I want you to do is go in your terminal, change directory to where you did your wget. So I'm going to just I'll just redo it. Okay, so here's my main.cpp down there on the bottom. And I can copy, or I could move main.cpp. Maybe we should do this using the Finder. Yes? Okay. But can you get to /temp? No, Apple hides /temp. Let's take an example. Jordan, where did you do the wget? In TMP?
Yeah, I made one.
Oh, in your own home directory. Okay. Did anybody else do that too? mkdirtemp? Good. Let's do that. Okay, so I'll be with you in a second. Okay, so with it in your home folder, you could use the Finder to find where main CPP is, select it, copy, Command C, and then using the Finder, I have to remember where I put the source code. Oh yeah, and go to where the project is located, and there should be, let me go remind myself, where's Xcode? So I'm hovering over this, and actually I could just do it this way. It's already copied in Finder, so I'm going to open this in Show in Finder, and I should be able to just hit paste and hit replace, because they're the same name. Should we do that again on the Mac? Okay. All right, so starting from scratch, where did you put your wget? In a temp folder? No? Okay. Did you do the wget? Okay. All right, so let's begin at the beginning then. That's okay. Okay, so if you have not gotten the source code yet, Okay. Are there any other Finder windows open? Oh, Apple. And such duty heads. Okay. Oh, I was in the wrong place. Okay. So starting from terminal, mkdir space tmp for temporary. Then change directory cd to tmp. Please have this open in Safari or another browser. Do you know how to get there? It's the raw, but you have to click on raw. This is the raw. So select the URL, copy the whole thing, come back to terminal, say wget, and paste. On the Mac, how are you doing? Good. Yes. Okay, so in your browser, there's the address bar, right? So if you're in Safari, click in it, well, in any of them, click in it, and the whole URL, Universal Resource Locator, is selected. Hit Command C for copy. Okay. So starting from Schoologies, which is sort of our ground truth. So go to main course page in the materials. Click on main course page again. Are you with me? Select 1810. Select lessons. Select 002. Click on main.cpp. And last step is RAW, raw. Then the complete address is in the address bar. Okay? All right. Now, we have, okay. You now have main.cpp in your temporary directory. Okay, now I'd like you to put it where your Xcode project file is. So we should be able to use the Finder for that. Are you able to, when you open up Finder, do you get a look at your own home directory? And is TMP visible? No? Andrew, can you help? Yeah. Well, let's see. When I click on the Finder to open it up, I say new Finder window. That's where I go. Does yours have your username at the top center of the window? Okay. It goes where? Recent. Okay. Goes to recents. Now, once again, Apple, think different. They want to hide where your home directory actually is. If you click on desktop, downloads, there is a certain key. What's that? Go. Go home. Excellent. Excellent. Thank you. Andrew, did you hear that? It says go home in the Finder. So up here in the Go menu, there's a Go Home. And thank you so much for showing me that. Now in there is that TMP. Copy it, Command C, and then find where you put your Xcode project. And if you need to be reminded where that is, where is Xcode? You can hover over, or actually you can right click on the name of the file and say show in Finder, and then put paste. And it'll say, just say replace. When you come back to Xcode, main CPP has been replaced. I'm going to hit the triangle, build succeeded, and enter 2 ages with a space in between, 20 and 30. Both can drive, at least one can rent a car, one can be senator, neither can be president, and the program ended. On Windows, let's try it here. Let's see, how does it zoom out again? Okay, so here it's called ages.cpp. You can hit the green triangle, and let's try that again. All right. Okay, so what I did to make it work is I added a space, and then I removed the space, and I saved the file. Then hit the green triangle again. Enter 2 ages, 20 and 30. Okay. Is everyone able to get here? Yeah, ZZ. Make the program? Right, so I clicked anywhere. I added a space. I took the space away. And then you can hit Control S to save. And then the green, you see up here is easy? The green? Good. Is everybody able to get here, whether you're on a Mac or Windows?
I'm not seeing, so I have main.cpp in my folder, but I'm not seeing that folder.
Okay. So you do see ages?
Yes.
Okay, so right click on ages. Sorry. Go to the ages tab. Right click on the tab heading itself and say open containing folder. When you do that, do you see ages and main?
Yes.
Okay, so delete ages and rename main CPP to be ages CPP.
Yes.
Okay? Okay. All right, so now I have an assignment for you to do at your desk. Do together. Down here at the bottom. So add a feature. If neither person is 67 or older, print neither can get Social Security. If only one, exactly one, then print exactly one person. If both people are older than 67, print both persons. So this is a little bit different. It's kind of like exactly one can be senator, but it's now 0 of them, 1 of them, or 2 of them. So you guys at your tables, figure out how to do that. And talk amongst yourselves, help each other. Question?
Hold on.
The green arrow is water.
So I think you have to be seriously.
It's really, it's
Like,
so it's supposed to be like
if you like, I follow what you feel.
Like this.
You're at buzz.
Yeah.
I believe that's all. We just copy these. And then, you see.
What are the bars? Right, how do you get
This, it's a shift.
Is that it's the same as this one.
So if it's an
Yeah, for full blast.
I think the second one.
You have a question?
No.
So this is going to combine a lot of what we've learned so far. You'll have to use an if, an else if, and an else. And my cup is way over there. Okay. Will you be long? Okay, so. So you come here first. No.
I think it's still good. So that would be 67. Oh.
Yeah, sure.
Should be ready to go.
Do one in the
And everybody's been working together, so why not join up with some other folks? And you're going again?
Yeah, we just.
Excellent.
Yeah, so I'm hitting one and it's giving me this.
So like 50 or something, and then.
I don't know what again.
It doesn't say anything about.
Later.
Yeah.
No, it's
Mm-hmm. So notice, folks, there's a neither, only one, and both. In your existing program, you have examples of here's a both, here's one, and here's a neither. So you could use this code as your model. But there's still going to be a difference. Yeah? Excellent.
You slide back to the other page.
Down here. Yep. There.
So like.
Hmm? Yeah, save it. Did you get it to work? Okay. Okay, we'll pick it up again next class. Because there's a very, very reasonable way to do it, but then I might be able to show you a different way of thinking about it.
Copy and paste it.
What are these else?
What is your office? What do you think?
Sorry. Because, like, I have it this way, and it works. Same place, something.
Right.
True, that works. But is that the most efficient way? Just consider all three of those cases.
We're putting more clarity.
Spread it out.
Let's say it's satisfying.
It works. I type your code.
This is not conforming. Just that.
Wait.
And it's
So, the hardest part about
That makes sense.
Well, you know what? You know what else, though, is check.
Sorry, I feel like figure out how to like get back
Make sure
to
it's
your
covered
that.
all
Now I
the
can.
But that's So now we're gonna be doing, so let's say do like 17 and.
So there was an important comment made. The hard part of this is you have to write all the tests. Well, really, you have included in that is you have to design tests that will completely cover all of your code. And the design of tests is critically important.
So like maybe one was when I was in their projects, and this was made up.
Okay, I'm gonna shut down and
Close after we discover.
yeah, close it after you save.